Jeez. Well, howdy guys. I just setting things up here. Well, I have coded off stream a bit, and I know it's been a while, but I have fixed, or at least I assume, I think I fixed the problem of the, basically what's happening was the label was causing many problems with the opcode. In the add sim stuff, I don't know what I fixed. I'm sorry guys, I legit don't know how I fixed this, but it works now. I used to be getting a weird, like the first character in the opcode was some non-ASCII character, and it was just screwing everything up. I have no idea what's going on. But anyway, I went ahead and I am still following the Brian Callahan's tutorial, part 6, processing more opcodes. So I added, so there's the no op, which is just opcode 0, and then I went ahead and added in a move and a halt instruction. Funny enough, the halt instruction is actually a move MM. I did not know that, but it is, so that's kind of cool. Excuse me. I'll go figure that out one day. Man, I didn't know it's a move MM, because move MM creates the same opcode as hex 76. Anyway, so as you can see, what's kind of interesting is there's an offset. There is an offset address, or not, there's an offset byte that you then add to the register bytes, which determines which register you were talking about. And if you notice, it's like the first so many bits are the opcode, and then the opcode family, and then the rest of the opcode is encoded in the other half of the byte. This is very familiar if you're familiar with like old programming, particularly like the PDP-11 or like the PDP family. This will be very familiar to you. I think most things use this. Anyway, let us continue on. So the next part of this tutorial is going to be adding in the arithmetic operators. So if I just do this, I got halt, move, no op. I can add in the operators. So I can do void add, right? And then there will be add with carry. There will be sub, subtract, right? There will be subtract with borrow. Okay. There will be and with accumulator. There will be or with accumulator. There will be XOR with accumulator. Let's see, subtract with borrow, and with accumulator, XOR with accumulator, or with accumulator, and compare, because CMP is it's not CPI, it's CMP is a compare register. So we're going to compare registers. Okay. There we go. And reg mod 8 is what decodes the registers for us. And again, this whole assembler is written in D, but I'm importing it to C. It's not too difficult. The big thing with C versus D is much nicer with strings. So be sure to include your own string library or write your own functions, and just to be aware of that sort of thing. string arrays are much nicer in D. Take it from me, so be aware of that. And then we'll go down here and we will add these in. Else if add, what was the first one? Yeah, add ADC. I'm sure there's someone could probably give me some sort of like a Vim or Redux syntax to do this much faster. But, and this is like the sucky part of this whole thing, but you gotta do it. And eventually I'll want to make a jump table for this. Just because jump tables are nicer, I think. Jump tables are much nicer. They definitely do have like a performance difference, but on a desktop it doesn't matter. But if I ever want to port this to my microcontrollers, it would definitely make a difference. In fact, I mean, if I want to port this to my microcontrollers, I don't even know. I'd have to like rewrite a whole lot of stuff. In a XRA, right? Yeah. XRA. Then 4A. Then compare. Was it 8080 assembler, Mac? I'm sorry, I didn't see your message right away. An 8080 assembler is a piece of software that takes your source code, and I'll show you. It takes this code, if you can see, and converts it into byte code, which is this code, and this is machine code. This is the stuff that'll run directly on the CPU. This is assembly code specifically for the 8080 chip. And the 8080 chip, Intel 8080, let me bring it down for you here. It is an old 8-bit processor that Intel made back in the day. And I have many computers that use this architecture. If you ever heard of the Zilog Z80, which is like the original Game Boy or Texas Instruments graphic calculators, even the new ones, they still use Zilog Z80 code, which is a superset of 8080 code. Basically, an 8080 assembler is a way to write code very atomically, very exact. So you do the exact bytes directly to the processor. That's what that is. I love them. I absolutely love these old chips. So this is just like, there's tons of assemblers already out there, but this is a good exercise in how to do it. And I've been walking through how I've done it throughout this entire series. Okay. So let us fill in these functions. So let's go up here. It should actually be fairly simple. So we're going to do pass act. Okay. First, we're going to pass in our which pass of our two pass assembler we're on. We're going to then pass, it's 1 byte long. Then we're going to pass 0x80, which is the byte in the family for the instruction, plus reg mod 8 parsed line A1. And of course, remember, oh my god, there we go. that this is a character, so we have to pass that in like so. And then, of course, this is a 1 byte instruction, only 1 byte big, so we need to add in the if passed 2, then output counter plus plus. If it was 2 bytes, it would be plus equals 2. 3 bytes plus equals 3. And the nice thing here is because all these arithmetic instructions are essentially the same, except for the family number, we can just copy and paste, baby. There. Add with carries 88. Subtract is hex 90. Subtract with borrow is 98. You can see that there's kind of a pattern to this madness here. And remember, this is all in wires throughout that CPU. And I'm reading a fantastic book. I don't have it on my desk right now. It's over there. But it's basically describes how to build a CPU from transistors and on a breadboard. And this isn't like I'm going to build a few logic gates. So this is a straight up processor, like microprocessor from transistors. I read it, and it like Neo waking up in the Matrix. Everything makes sense. It's pretty crazy. Anyway, let's continue. And with the accumulator, that family is A0. XRA, XOR, the accumulator is going to be A8. Looks about right. I'm just checking up here. A8. Or A is B0. Zero. And compare is B8. Okay, so now also just to let you know, the D code does not have the pass equals 2 output counter plus plus. That's because I'm building up my array in C instead of using the D as append. So let's build it. Looks like it's built. And now let's change this code to something more. Here, let's try. I move B to A, and then let's add B. I will add B to A. Now let's do move A to M. And then do compare M. So, and then let's clear A. XOR A with itself. And no op. Now let's try building. Now let's try assembling it. Okay. This here is the output. Let me bring this down for you. Let me shrink this here. Let me load this up here. Let me try here. So move A, B, add B, move A, CP, XOR A, no op, no op, no op, halt, assemble. Okay, let's look here. The first one is 78, the next one is 80. Next one is 77. The next one is BE. The next one is AF 00076. We have a working assembler, folks. It works. My assembler works for all the instructions that we have. My assembler works. That's pretty awesome. That's pretty awesome. Now, of course, I don't know if like the label table works, but that's future Patrick's problem, right? Next up is teaching assembler how to encode the fourth quarter of the opcode table. Here is a more variety of instructions in the first and fourth quarters compared to the second and third quarters, but after tomorrow, our assembler will be able to assemble interesting programs. Let us find out. So we're going to go next. This guy really did. He really did like post the day after too. That's kind of fun. Let's see here. Arithmetic on immediate. So we're going to be doing immediate instructions. This will be fun. The instructions are add immediate, add with carry immediate. I've never heard of ACI. Add with carry immediate, I guess. Subtract immediate, subtract with borrow immediate, and immediate, XOR immediate, or immediate, and compare immediate. A new challenge for us is to tackle. Each of these instructions takes a single argument, but this time it is an immediate. So instead of a register, this is now something else entirely. Okay, processing 8-bit immediates. Let me pull this down for you. There. Okay, let's look at this together, folks. So get an 8-bit immediate. So private void immediate, you shorten bool found equals false. If is digit A0, so if the first digit of your first argument is, if the first character of your first argument is a digit, then cool, you have an immediate. If input length minus 1 equals h, I think what this is saying is if the last character of your argument is an H, then do a base 16. Do a base 16 conversion. Else do a base 10 conversion. We can do one better. We can add H and an O. So we can do base 16 and base 8. So we can do hex and octal. I'm confused why it says input length minus 1. It's saying the line. If the line minus 1. That could be a problem. I'm silent because I'm trying to think here. I'm going to do is I'm going to find the last character of the argument 1, and if it is an H or a 0, sorry, an H or an O, do the do this thing. Do the base conversion. But before we do the base conversion, change that last character from an H or an O to an end of line character. Then we'll do an ATOI, okay, to set to num, okay. Else if pass equals 2 for size less. If A1 equals what? 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 Hang on, I'm sorry. We're running into the problem where if the argument 1 equals a label, because the label sometimes is defined as something. So basically, I want to and immediate with like mask, right? And you put in mask. Let's continue on before I start implementing this. This will not be the final version. The function works for right now because eventually you need to extend its support to 16-bit. That's going to be fun. Eventually, we will need to support the user inputting either decimal or hexadecimal numbers. The original ZPM can also binary and octal. We can add those later. Yeah, B or O. That'll be fine. We can also do like prefix instead of suffix too, so it can be extremely robust. We can instead use a label to substitute its value, and if the first character of A0 is not a number, then it must be a label. That's what the else is. But let me start writing an arithmetic on immediate functions. Add immediate. Here we go. If it is ADI, then pass act C6. I think if I look here on pass act, I can go to pass act and then say basically on size, I can do output counter plus equal size. Let me try that right now. It's actually quite amazing how many people ask what is an 8080 assembler. No shade, no shade. it's just kind of crazy because like you click on this video, and I'm assuming you would know it like because it's such a niche thing. I would assume that you would have an idea of what it is, but if you don't, that's totally fine. Like no worries at all. Cool. Let's try that. Okay, let us look just again. 78, 80, 77, BE, AF, 0, 0, 0, 76. It works. Cool. This is the correct. Cool. And then I can just take this. It's really interesting because like if you look at this, I could point you to a function that contains just like a pointer with arguments, and I could turn this into a chunk table really easily. I would like to work on this more frequently, guys, you know? I would really like to. I think I will, because I have the hard part was done. The hard part was getting that stupid bug fixed. I still don't know why. You know, don't ask questions. I know I should do arg check, but I really don't care. I truly do not care about arg checking. Now, I will add it. I will add arg checks, but it's really not important right now. Cool. Anyway. Did you write the same functions I did? Now you can look up the mnemonic list for process and the process function. At this point, you can put any arbitrary number into A using ADI and then move. Fun. Push and pop and exchange. Yeah, the push and pop is easy. Control instructions, out, in, interrupt, enable, interrupt, disable, jumps, calls, and returns. Now we can get check no argument. All returns takes no argument at our byte size. All jumps and calls take 16-bit addresses. All argument, therefore, 3 different bytes in size. Let's get the function process a 16-bit address first. It's a little different than an immediate. Oh boy. I don't think I'm gonna hit all of this tonight. Good God. Yeah. Reset vectors. They push program under the stack and then jump to address 8 times reset vector number. This means it should be just. It's really interesting because like basically what's happening is the reset vector. You have in the beginning of your code is just basically going to be nothing but reset vectors. Basically, you need to load your RAM and then copy your reset vectors into your RAM elsewhere. So then you can start doing stuff. Basically, your first instruction should be a jump to other place where it overwrites that jump in RAM from stuff from Flash. And that's how you load your OS. We're getting pretty close, folks. We're getting pretty close. This is fun. So what is the rest of the instructions? Logical shifts and rotates, increments, decrements, small tweak to reg mod 16, coding increment and decrement. Alexa, ooh, the fun ones. Load immediate. Move immediate. Yeah, baby. So we're really close. We are really close to being done. Let me try implementing this function. So void so u short and 16 to u int 16t num bool found equals false. Line.a1. So if the first digit of A1, the first character of A1 is a digit, then we will run this. If EOS parse line.a1 equals h, then we're going to do the num equals itoa parsed line.a1 16. And then we can do, if it's O, base 8, and then if it's B, do base 2. Cool, we can do that. Then this whole thing, what is going on with my music? Okay. I like how it just figured out that everything is like a lie. If pass equals 2. Let me change my music here. I don't know what's going on. Okay. pass equals 2. Basically, the stab length howdy guys. I'm trying to get the energy to finish this. Here. I'm gonna grab this. I'm gonna come down here. I'm going to okay. If end of array break. Okay. What it's looking for if A1 equals if A1 equals then let's take a look here. Then hang on. Gotcha. Then num equals s tab I dot value. I gotcha. Found equals true. Break. Then STD rule. Cool. Then if not found, label cool. Then at the very end, if pass equals 2, yeah, right at the end. Yeah, I'll have to figure out that. Anyway, there. Then I'm assuming I just increment things. Okay. ATOI, isn't it? It looks like it is. Converts to a long integer. I'm just assuming that there's this string to int. What is this? Okay, I'll just change it to string to long because that's apparently standard. ATOI is, yeah. And then EOS. EOS will be up here. Drink your water, folks. Good stuff. So I've been silent for a bit. Basically, I'm trying to create a function that will turn an immediate value that you've typed in into a integer for the assembler to deal with. But remember, you can also type in labels. That's where this is coming in. What? What? What the hell is a restrict end pointer? What? I have no idea. Cool. Anyway. Right. For I equals 0, I less than I s I not equal to 0, I plus. So basically I'm going to see if it's the end, then I minus 1 So I'm going to use a for loop to increment a counter. Then that return the character that is at that counter minus. Yeah. Cool. I think that should work. Is it thread is like safe? Absolutely not. But don't worry about it. That's for a future project to worry about. A minute builds, dog. Let's pull up the immediate seems to work, so let's put these tentatively in. Okay. Let's try ADI 42. Boom. Let me look. Equals ATOI parsed line dot A1 ITOA parsed line dot A1 ATOI. Cool. So if there isn't any prefix or postfix, it is base 10, folks. Cool. Let's go down here. Void ADI, AD, and pass act, pass to it'll be size 1. And why is it size 1? Because, well, one moment, I'll get to you, Gil. Because I'm actually incrementing it in the immediate function too. So it'll be itself. Anyway, what is a switch instead of 3 else ifs? I believe you're referring to this. I could. You're definitely not wrong. It's just a lot easier to write in this case because switches really work best on like bytes and stuff like that, not functions and function returns inside. I totally could. In fact, I did do what you're saying. Where is it? Here, kind of. I did it kind of here. I could have just done an if thing, but I did a switch. So future Patrick, if I really want to, I will do a switch statement, but it's just not necessary right now. Remember, folks, optimize afterward. Don't optimize right now, because, bro, if we optimize right now, we're never getting anywhere. Get rid of that point. Here. Anyway, yes, it will, as I was saying, it will increment anyway. ADI 0 C6. So, and then immediate pass. How do lol thanks Zepha said how do numbers work in D? Because you know what, let's try, you know what, I'm going to just put this up here as a global, because I know that's terrible, folks. Don't ever do that. Don't ever do that. Don't ever do that. Especially not named num. It's just, I set num in pass 1. No, wait. Yeah, what am I doing? No, never mind. We're good. Question, have you thought about using Vim or something? I would be frustrated with the amount of scrolling. So yes, I actually use Vim a ton. I do use it an absolute ton. In fact, for making things on the Altair 8800, I use nothing but a screen editor. I use WordMaster, which is a VI thing from like the 70s, like a step above Ed. So I'm very comfortable using Vim. I'm not comfortable memorizing all of the keyboard bindings. I know it's a skill issue, but that's just me. I would much rather see the visual representation on the right and scroll, but I'm sure if I were to sit down and actually figure it out, it'd be fine. Vim would probably be much easier. Also, what's nice here though is you can zoom in much nicer, and specifically Vim I love using the raster fonts, the 8x12 pixel raster fonts, and on such a big screen it's so small and you guys would not be able to see without me doing crazy stuff in OBS, which is again a skill issue on my part. If I really wanted to, I would also put on the Vim extensions for Visual Studio. But if I'm not going to use the Vim key bindings, then what's the point? So we'll get to it. But anyway. Right. Did you ever use, actually, I'm using Eclipse right now. Actually, I'm using Eclipse right now for the STM32 boards. In fact, not specifically Eclipse, but IDEs that use Eclipse. So like the STM32 IDE. So this thing right here, yeah, thanks, yeah, thanks, Josefa. Yeah, I'll do it. I'm not quite sure what you mean about Insky. That's probably a joke that's over my head. I'm just a programmer. I don't know. Yes, this is the assembler that made LeBron cry. Don't worry. But anyway, as I was saying, STM32 Cube IDE is an Eclipse-based IDE for the STM32 boards. I've used in my previous job a ton, and I absolutely love it. If this decides to open very slowly, yes, right. This is essentially, it's essentially Eclipse, and in fact, thanks, man. I don't know if you can see, but this is an NXP board, which is essentially it's the same board as the STM32 board, the same chip. It's just a different vendor, NXP, and it uses MCU Expresso, which is another Eclipse-based IDE. That one it's proving to be more difficult to navigate, especially for the pin configurations, but skill issue. Anyway, back to coding. As far as I can tell, this is going to work. But let's see if it does anything. Okay, let's see. So the first one should be ADI 42. That's not promising, folks. That's not promising at all. Okay. Oh, no. You know why it didn't work? Because I didn't put the goddamn chicken. So way down here. Halt, move, process. Where did I put ADI? I see what you mean about scrolling. Right here, before the move. So let's go down here. Before the move. And then instead of no op, let's do ADI. Else if anyone told you that you look like Jesse Einsberg, that's my out of context comment. No worries. It's funny. I love that. I love that shit. No one's told me specifically Einsberg, but I do look like a lot of Jews. We got the nose, and when my hair grows out, it really looks like it. It's slightly curly. Adam Sandberg? Yeah, I don't see me looking like these photos, but like this one, or like like that photo, or like maybe this one when my hair grows out a little more, I can definitely see it. It's disheartening. I don't think he looks cool, but he's recognizable from some shows, so Bro, that's you. It's literally you. I know, I know. My birth mother is, as far as I can tell, was Jewish, so that it makes total sense. Um, but yeah, I get told that all the time. Thanks, man. At the literally at a cafe, at the gym, stuff like that all the time. Man, this chat is on fire tonight. Um, anyway, right, I added in the ADI, the add immediate. So let's just see if it does anything. It still builds, but I'm not gonna put any stock on that. ADI 42. 42. It works. Okay, it works. But why is there a why is there a because it's not past 2. Because if I go to immediate, and I look, no, it should be past 2. It increments only in past 2. What are you trying to do? Jagged, I'm so sorry if I'm mispronouncing you guys' names. I know I am. I'm trying to make an 8080 assembler. Right now what I'm trying to do is I'm trying to do the part where you take an immediate operand instead of a register operand. I'll show you what a register operand would look like. A register operand is very easy to do. You basically just do a little lookup table, right? This, like this. Like, oh, I'm doing add B. I'm gonna add register B, so I'm gonna return the lookup table for B. But if I want to do I'm getting very animated. I hope I'm not waking up my roommates. If I want to add an immediate number, basically you have to, is that number hex? Is that number octal? Is it number binary? Is it number base 10? And then that's going to be the number instead. But also, what if I do this? What if I do something like BDOS equals 5, and I want to, for some reason, I want to do ADI BDOS. Now I have to have a symbol table of what does BDOS equal, and then that's why it's become so much more complicated, but it becomes so much more powerful. I'm not doing the label part yet. That's going to be like tomorrow or next week or something. The problem I'm having right now is the fact that I have an increment before everything else happens. See, look, C62A is the opcode for ADI 42. But it should be the first one. It shouldn't be 00. So let me try no op in the top and see what happens. No op. Yeah, so for some reason, no, you know what? Instead of no op, I'll do you one better. XRA A. I'll clear A first. My God, I'm losing it. Okay, assembled. What? What did I do? What did I fuck up? What did I fuck up? What did I fuck up? I don't know what an ADA assembler is. An ADA assembler is a piece of software that takes your assembly code. So this right here is assembly code. It's a kind of programming language. It's not strictly a programming language. It's a mnemonic programming language for machine code. And machine code is what runs directly on your CPU. So instead of typing in the literal ones and zeros and hex numbers that will run directly on your CPU, you can write it in somewhat human readable code called assembly. And it will be a one-for-one, mostly asterisk, a one-for-one direct copy to its corresponding bytes and bits that runs directly on the CPU. Nowadays, it isn't done much anymore because CPUs are just so massively complex and the instructions are so huge. They can be up to, I've worked in assembly on chips where the instructions are 128 bits long. It was crazy chip. It was a crazy chip. Exactly human readable. For me, it's human readable because I'm a complete nerd, and I just do this all night after I do stuff at work. And I've also been doing this for a few years now. You can actually look on my channel, and I actually show you how to do this, how to even convert C to assembly to run on old machines. But anyway, this assembly is an 8080 chip, and this is a chip, an old processor that Intel made about 50 years ago. 50 years ago, exactly. And hash functions, are you in university or just where? No, man. I failed out of school. I mean, when I say I failed, my parents had to pull me out of school before I ruined their investment. Like, that bad. So, I'm telling you, you can do this for a job and just not go to school because I'm living proof of it. If I can do it, so can you. The key is you need an interest in it, and you need to want to do this. You can't go into this field just looking for a quick buck. You will get burned out so fast. You will just lose all interest. What I'm doing for work, I'm actually working at Noregon. Noregon is a vehicle data company, and it sounds kind of boring, but basically what we do is we provide alternate solutions for your vehicle instead of going to the OEM where you could pay thousands and thousands of dollars to fix the computer. We can do it we're a different vendor. Let's just put it that way, legally speaking. And usually we can do it for cheaper. And our tools work on many vehicles instead of just like a Toyota or something like that. When I say vehicles, I mean like I'm actually working on Ford right now. I'm working on the UPS trucks. You're working on those computers. Oh yeah, I know you're my competitor. Oh man, the Allison guys are in the chat. Get out of here. Yeah, I like it. Yeah, my previous job was military research and development, and that I love by far. That is my most favorite job. What do you do there? Do you make all the software or something? I'm not. It's not like top secret. I gotcha. That's so wild. That's so wild that we're on the chat. I don't make production software. I'm the research and development sector. I research and develop things from the field, and then once we figure things out, we send them off to people who actually know how to code for real, and not like me, monkeys on a keyboard, and then they'll make it into the production software. So, yeah, Insky knows what I'm talking about when I can't get too into detail because there is some legal dubious stuff. I don't want my boss watching this stream and yelling at me or getting me fired. Yeah. But yes, I definitely enjoy programming microcontrollers and stuff much more. But the plus of this job is when you get out in the field, it's so fun. It is so fun. You get to like try different vehicles and experiment and stuff. It's real fun. Like there's definitely slow parts to this job, but when it's going awesome. Anyway, yes, bring it all back. This assembler is for this old chip. This chip has 4,500 transistors. That's how simple it is. And as you can see, like as I've said before, this chip also is the Zilog Z80 is the superset of the 8080. And the Zilog Z80 is in your TI-84 Plus. It's in your TI-84 Plus Color Edition. It's in your TI-84 Plus CE, kind of. It's an EZ80. It's better, but all that stuff. Exactly, Jackie. Jackie, you're trying to say exactly what to do. Exactly. There's no compiler. There's no interpreter. It's you and the chip, and that's it. Thanks. So maybe writing somewhere for a 50-year-old CPU, there might be maybe 100 people with a dedication to this stuff. Oh, thanks, Tyler. Oh, I'll drink to that, bro. No, you're right. It's a niche thing. Oh, I'm also listening to a Stranger Things soundtrack while I'm doing it too. You gotta get in the zone, in the flow state. Anyway. Yeah. Let's try to get back on track here and solve this problem here. So if I can probably just comment out there. Let me comment these out. Build no op. 78 is move AB. That's good. Let's do an XRA A. AF is XRA. Somehow adding in the ADI 42 fucks everything up. Yeah, it adds in that for the next GeoHots. Quickly GeoHots. Looking this guy up. GeoHots. Is this a... Oh, oof. Who is this guy? American hacker and entrepreneur. Interesting. Huh. Why, thank you. Flattered. Is he the dude who did... he is the dude that did... Okay, some of this Android rooting stuff. I have heard of this guy back in the day. Yeah, he's done a ton of stuff, hasn't he? He really has. Goated dude. The chips he works on that were a little bit too new. I know you can't see it, but that blinking light stuff over there, that's a PDP-10 emulator. I do that stuff. Please in your free time watch some of those coding videos. You were so similar. I'll take a look. Is he active still? Or is it like, is he Twitch channel. Breaking this program live streams. Okay. I will take a look. No, I said Twitch channel. I didn't want to go to Wikipedia page for Twitch. It's Twitch. Yeah, here we go. I'll take a look at this, folks. Thanks. Yeah, he just hops on, in and out, just randomly posts stuff and then goes missing for months. I feel that. I'm sorry, guys. I also have been neglecting my main channel. I haven't sat down and made a video for the 8080 or anything like that in a while. I've been meaning to. It's just, yeah, life gets to you, unfortunately. There's many things I want to do, but yeah. Anyway, let's look. The ADI instruction, for whatever reason, shifts, let's see, 9, 10, 11, 10, 11, but then it adds 1. Why does it do that? Let's look. Go to ADI. Void ADI. Go to immediate. What's going on? Let's try that. Obviously, it's not going to work the correct way, but that's okay. Is that what I did? I didn't. Retard alert. I didn't put these in parentheses. So only the first one ran, and then the counter ran every single time. X-array, ADI, AF. I think it works. Let me plug this in. XRA, ADI, 42. Assemble. Thanks, Insky. What about your roommates? They're sleeping right now, and I'll find out in the morning. You're gooded for the triangle. Thanks, man. Actually, I have a there retard alert button too, just for this. In particular, what are you trying to make this chip do? I'm so sorry. Right now, I'm actually not trying to make the chip do anything in particular. Right now, what I'm doing is I'm making the software that turns this human readable code into the bytecode that will make the chip do things. I'm making an assembler. You know how you have C and you run it through a compiler? I'm making that. Now, it's not a compiler, it's an assembler. It's the last half, the compiling. But that's what I'm doing. I'm making the tools that will let me make the chip do whatever I want. So all that code that I've written in my previous videos, I could run it through this assembler when it's done, and it'll work, instead of using the native CPM assembler. CPM being the operating system that runs on the 8080 chip. It's not really an operating system, it's technically a monitor, which is something different. Yeah. Anyway, let's look. So we have AF, we have C6, C6-2A, 78, 80, 77, BE, AF, 000, 76. Sweet. And Jajit, basically what I'm doing is I'm checking my crappy assembler against a known working assembler. And if the outputs match, that means my assembler's working. We're we're making some good headway on this. I didn't expect to get this far tonight. Basically, yeah, I did. Thank you. I did sub with immediate. No. So I did ADI. Now, let me ADI, let me here void ADI ACI pass act pass 1. This is going to be 0C6. This will be 0CE. In pass. And then so add with carry immediate, subtract with subtract immediate. Subtract immediate is going to be D6. Okay, and then SCI subtract, sorry, SBI subtract carry, subtract immediate, DE, and then ANI and immediate. This is just the unfortunate long part. E6, and then XRI, XOR immediate. XOR immediate is going to be E. And then OR immediate. OR immediate is going to be F6. There's definitely a method to this madness, if you can tell. And then CP I, load bearing I. CPI will be FE. Okay. I had it so optimized I can no longer read it, so I just did a complete rewrite. Exactly, and I'm not sure, but I think, yeah, I did say that specifically on my Sim 1 C roguelike, because, yeah, I yeah, exactly. Optimize later, don't optimize now. Again, this could be a jump table. And I have a live stream a few years back of me making a virtual machine on one of these old CPUs that used a jump table. Okay, then let us, here we go. There, ADI. Oh my god, I hate, your guys are right, I hate this scrolling so much. ACI. And SUI. C. SBI. ANI. XRI. Actually, you know, like so many of these opcodes I actually have never used, but I gotta add them, gotta make it complete. CPI. Okay. When it builds, let's just throw in a CPI somewhere. CPI 0. Let's do that. XRA CPI CPI 0, assemble AF FE 00 00 00 00 00 76. It works. It works, folks. It just works. When you do the thing and you do it right and you don't fuck it up, it just works, said a wise man. Okay, what time is it? Is it 1:32 already? I'll try to put in a couple of these functions. We're gonna put in push pop. Well, yes, we'll put push pop in the exchanges. Let me look. Push pop. Yeah, okay. Okay, let's do that first. So I'm going to go up. If you can't see, I have the this here, this sort of step-by-step of what the guy's doing in D and importing it to C. So yeah, okay, let's do this. Bytes reg mod 16 char ch return 0. Then switch ch. As you can see, it's getting later because it's getting harder. Case B. Yeah. Equals 0. Break. And then case B, C, and then D, E. Then HL, Xerox 20, and then PSW. So rewrite for better checks. I don't care. I'm just gonna fix that. One moment. Default. One moment, Shagit. I'm on a roll here. I will find out what you're saying. Okay, let's see. If you break, will it return 0? Okay. So, right. I just put return 0 so I wouldn't see that stupid red line, because byte implies a return statement. And the IDE's linked program will flag it as an error if you don't have a return statement, a valid return statement. So that's why. And at the end, yes, I will return num. Yeah, basically what the P thing is, P. The P thing is basically if I type in PSU instead of PSW, it'll still work because I'm just checking the first character. So yeah, I should do something a little better, but whatever. That's why they use if statements instead of a switch statement, because yeah. Anyway. Okay. I am should I? It's so late. It's so late. You know what? Let's risk it for that biscuit. Let's do it. Let's do it. Let's do at least XTHL, PCHL, Exchange, and SPHL. Why not just make it so I can literally do that. I can like to upper. I can do that. I'm lazy, even though that was easier to do. Shut the fuck up. No, you're right. You're right. I'm tired. That's my excuse. I'm tired. Yeah. This technically is faster anyway, but who cares? Anyway, right. I'm gonna do these. Let's do these. Let's do these. Void X THL pass act pass 1 0x-E3 and then what's next is PCHL. So push, and then this one's going to be E9. And this is going to be the all-important exchange. Exchange is going to be EB, and then SPHL. I never use really SPHL. The only thing I've used it is just changing my stack to local stack. Is going to be F9. Cool. And then let us go right here. And then let's start writing them. XTHL, XTHL, and then PCHL, and then exchange, and then SPHL. Let's try building. Let's do a couple swaps in here. Let's do exchange while bro. I'm just throwing a comment in there just to keep the assembler on its toes, you know. Let's do a PCHL down here. And then let's be sure to punch that in here. Exchange after the ADI. And then a PCHL after the XRA. XRA PCHL C50 assemble. And then go up. Let's look. Let's look. So AF C62A EB 78 80 77 PE AF E9 FE 00000000 76. It's working, folks. It is working. It is like once you make the core, I think the hardest thing was the parser. The parser was the hardest thing, and in fact, that's still not quite done. What was happening with, I'll show you what's going on with the parser. So the parser works wonderfully, but there is a small problem. The small problem comes from when where is the parser? Right here. So if I want a label, I have to do this. So label space opcodes. If I did label colon opcodes, it wouldn't actually work because it parses the spaces first, then or I don't know. I don't think it would work, and I haven't tested it. I'm probably talking nonsense. Anyway. Let's excuse me. Look at what this guy is doing next. Okay. Push and pop. Let's do it. Let's do the push and pop. We're gonna do it. We're gonna do it. It is gonna work. I can go to bed knowing that this will work for this part. After the push and pop, I'm gonna go to bed. Okay, because I've been up late. I'm gonna do push and pop. I'm gonna watch some fairy tale because I hate myself, and then I'm gonna go to bed. Okay. Void push pass act pass 1 0C 5 0XZ 5 plus reg mod 16 parsed line dot A1. Cool. And then pop just be C1. Yeah. Okay, let's check this out. So then, okay, actually, that's a fantastic question, Gigi. I'm so amazed that you're sticking around here. Does pushing just mean you're giving the chip some instruction? Sorry. No, but I understand why you would think that. Pushing, okay, it's high concept, but it really isn't. CPUs, pretty much every single CPU out there has something called stack. And pushing and popping refers to pushing things on and popping things off. Let me see if I can find you a good idea, a good visual representation of what's going on with that. Let me look at images here. Here. So picture a section of RAM looking like this, okay? A section of RAM. It's not your entire RAM. Ignore the hentai games in the corner. It's a, think of a stack of plates. When you push a plate onto the stack, you take your current plate and you place it on top. Exactly, Jackie, yes. And then when you push, the most recent thing you push is on top of that stack. And when you pop, you take what's on the top and you pop it back off. I think that's called FILO, first in, last out? No, first in, last out, LILO, I think. Yeah, last in, last out. LILO, no, last in, last out. But the important thing to remember here, at least for this CPU and in many CPUs, is that this is actually a location in RAM. You're going to have something called a stack pointer. Instead of a physical separate block of memory, you're going to have a pointer that points to some place in RAM and will increment and decrement. So when you push, you take whatever's in register BE or BC or DE or HL, and you take that and you push it to where that pointer is, and then automatically that pointer will increment. Not always. Some CPUs you have to manually increment and decrement the pointer, and that's a pain in the ass. But the CPU will automatically increment or decrement. And then you push your next register pair, you push your next register pair, and then when you pop, you take what's at that current pointer and you put it into whatever register pair you say, like pop BC. You pop whatever's there into BC, and it will decrement, and it'll keep going down the line. There's some instructions that will allow you to manipulate the stack pointer yourself. So this instruction, SPHL, will mean, I think it's swap HL and SP. So whatever is in your register pay HL will now become the stack pointer. So you can change the stack pointer to whatever you want. It doesn't have to be at where CPM says your stack is. In fact, if you look, flashbang, I in my terminal program that I wrote, this is an 8080 assembly. Here, I have local stack pointed to something called stack top, and stack top is down here, and basically what it's saying is I have 128 bytes of stack for this program locally. Default, CPM only has 8 bytes of stack, or 16 bytes of stack, so eight addresses. And stack is important because, and this is true for every chip that you've worked on, when you go into a function or out of a function, like into it or out of a function, your current address in your program is pushed and popped from stack. Or return functions will be popped onto stack, or pushed onto stack and then popped in. Your arguments will be pushed onto stack or popped from stack. You may have seen an AC. I'll get to you in a moment. But Jackie, if you ever heard of pass by reference, don't pass the entire struct or something, because if you pass a struct into a function, you're pushing that entire structure into stack, which is such a waste of memory. You can just push the address of to where that structure is onto the stack, which will save stack memory, make things a little faster, and especially for these older chips, save a lot of space in your program. But yeah, also if you pass by reference, you're pointing to another place in your code, and that's why certain things will stick after a function, and some things are local to a function, and some things aren't local to a function. That's what that is. That's address stuff. Anyway, I was getting off the rails there. AC, please let me know what 8080 assembler is. The short of it is I'm writing the last half of a compiler. So when you have your C code, and you write in C like I'm doing here, you compile it, it will compile it to assembly, which will look like, this isn't x86 assembly, this is 8080 assembly. This is code which has 1-for-1 numbers in bytes that will run directly on the CPU. For instance, the instruction XRAA has the byte AF. So when this old CPU, wherever it is, this old CPU that Intel built 50 years ago sees instruction AF coming down that data bus, it knows to XOR the A register with itself. So it's human readable code. And my program, what I'm doing, the assembler, will take this human readable code and put it into machine code, and then you can run that directly on your CPU when you run a program or something. I'm doing this for the 8080 chip, which is a very old chip, and you can't see it, it's not turned on, but I have an Altair 8800 emulator, which emulates the 8080 chip. I have many videos on my channel about it. There's many videos of this on YouTube. But yeah, I've decided to write my own assembler for it. Eventually, after this assembler, I want to write my own compiler. A true compiler for the 8080. And ideally, I want this compiler to run on the 8080 to compile itself for the 8080. Because I regard people who can write compilers as gods, essentially, in programming, and I want to do that. In no better way than just sit down and do it. Whew. Anyway, where are we? Right. What I'm doing is I am doing the else if XTHL and then CHL. And then, no, what am I doing? Right. Push. Let's pop. Shit. Right. Have a good night. I'm gonna take off. Hey, yeah. Good night, Jaggy. I hope you join back up again. Real good talking to you. Push H, pop B, assemble, build, okay, it looks like it did something. Let's run through the thing. AF, C62A, EB, 78, 80, 77, BE, AF, E9, E5, C1, FE, 00000000, 76. It works, folks. It works. The rest of this is out in interrupts enable, interrupts disable, but then the fun part's going to be jumps, calls, and returns. Yeah. I'm just looking through next time. Yeah, I think this is it. We're on the home stretch. We are on the home stretch of this assembler, and I can't wait. I really can't wait. I have a working disassembler and a working assembler. I'll have a working assembler, and what I really want to do is I want to have a multi-linking assembler where I can have multiple files, like source files, because that's something that native CPM assembler does not do. Now you can do the macro assembler, but no, I know what I want. Well, that's it, folks. I will probably watch an episode of a show to wind down, and I will see you next time, hopefully sooner rather than later. Alright, guys.